Right, now we're going to look at the alternative form of the parabola, something which should look familiar to you. If your parabola equation is in this form, then it immediately gives you the turning point. And in the previous lesson, we spoke about it being helpful to have the turning point. So this is a good time to talk about the completion of the square. Because how do I manage to get my equation into that form? Well, I think the easiest is to actually look at an example. And I'm going to look at the example where y is equal to 2x squared plus 8x plus 7. Okay, now the way I go about doing it is I take out the 2 as a common factor out of the first two terms. Of course, you could take it out of all three terms, but this one actually works a little easier, especially if you can avoid working with fractions. So what happens is you now take this one over here and you divide it by 2. So you get x plus 2, or rather you took your 4 and divided it by 2. So what happens now, if you check your answer and I'm squaring it, then I actually get x squared. My middle term is 4x, but there's also a plus 4 there, which shouldn't be around. So I'm going to subtract that 4 at the same time. And there's the plus 7 still waiting for me at the back. So basically, what has happened is the following. If I now multiply my 2 back in, then it's going to be 2 times minus 8 plus 7. And there you go, 2x plus 2 and then minus 1. So what is my turning point? Well, of course, it's then going to be minus 2. Be mindful of the negative there. And minus 7. And there you have it. So that's the completion of the square. Okay, one other thing that we might want to have a look at is something called quadratic inequality. Now, quadratic inequalities plays quite a hefty role in your mathematics going forward. So it's worth it to think about it very carefully. And I want to take an example again to demonstrate what we need to do. Well, there's your function. And I'm asking you to determine the values of x for which, well, first of all, the function is greater or equal to 0, and also, where will my function values be less than 0? And of course, there are once again many ways of going about this, but by far the easiest is if you've got a graph. What happened? Where am I? By far the easiest is if you've got a graph. So let's go and sketch that graph quickly. Well, I can do it very quickly just by looking at the intercepts. I'm going to say if x is 0, then of course y is 0. And if y is 0, then 3x squared plus 6x equals 0. Take out 3x as a common factor. And I get x is 0 or x is minus 2. So if I had to do your sketch here, then it would look like this. X is 0 or minus 2. My a term in front over there indicates that it is the right way up. And really that's all I need, because If I now ask you for which x value, so look on your x-axis, this is your x-axis. Looking on your x-axis, for which x values will your function values be positive? Well, everything above the line says that my function values, in other words, these values over here, are positive. So for which x values is that? Well, obviously for the x values lying over there. So my first answer would be, number 1, my x values, and let's write this down write this down in terms of intervals. Then x is an element of. So where do I start? At minus infinity, and I go up to minus 2. Is it included? Well, yes. And then, and remember we've talked about this as well, I start again at 0 and carry on until I get to infinity. My second answer is now also just about obvious, because it will be these function values down here at the bottom that will be negative. And now do I include the minus 2? X goes from minus 2. No, I don't, because that's just a less than. So it starts at minus 2 and carries on until I get to 0. And we are done.